So in this video, we're going to look at what are called discriminants. Now, the discriminant is the b squared minus 4ac from the quadratic formula, which is what's inside the square root. Now, you can see here, if this was equal to 0, so b squared minus 4ac is equal to 0, we don't have two solutions. We just end up with minus b over 2a, which is one solution to my quadratic equation. And how we would identify this would be what's called a double root. So it just touches off the x-axis at one point. It could be a minus x squared and touch off the x-axis, for want of a better graph, at that point there. So there's three things that b squared minus 4ac can be. It can be equal to 0. The one that we most commonly come across so far, b squared minus 4ac, could be greater than 0. And when it's greater than 0, you can see in the quadratic formula, I'll write it out again, plus or minus a number that's greater than 0. So let's say, we'll just give any number, let's say 10 over 2a. So you can see here, we're going to get two solutions. So when it's greater than 0, we'll have two distinct roots. So it could be like this. Could be like this. And it could be the inverted version of these. So two solutions, two distinct roots. And the third thing that it can be, which we will look at in complex numbers, is when b squared minus 4ac is less than 0. So the square root of something less than 0, let's say minus 4. Let's say we get a minus 4 in there. Now, using the rules of surds, that's the same as the square root of 4 by the square root of minus 1. And we're told in complex numbers that I squared is equal to minus 1. So I is equal to the square root of minus 1. So this becomes 2i, which some of you may have seen already in complex numbers, some of you may not have. So when b squared minus 4ac is less than 0, we can say that the discriminant has complex roots. So in this lesson, we're just going to look at a couple of questions where you're asked to comment on the nature of the roots. So let's have a look at those. So pause the video and give these three a try. Calculate the discriminant and comment on the roots. So b squared minus 4ac is 36 minus 4 by 1 by 5, which is 16, which is greater than 0. So therefore, two distinct roots. Number 2, b squared. You can put in the minus k to be squared if you want, but anytime there's a minus number to be squared, it's going to be positive. So minus k squared, minus k to be squared, minus 4 times a, which is 1, this 1x, times c, which is minus a squared. So we're going to get k squared plus 4a squared, which both of these numbers are greater than 0. So therefore, this is greater than 0. So therefore, 2. I'll just write dr for distinct roots. This one here, just fill the information in and see what you get. So we're going to have b squared, which is a minus 1 to be squared, minus 4 times 1 times minus 9, which is a minus 1 squared. You don't need to multiply out the bracket here, plus 36. So a minus 1 squared is a square number. It's greater than 0. So is 36. So greater than 0. Therefore, again, two distinct roots. So a nice easy topic. You just need to understand what the discriminant is. If you don't know the meaning of the word, you'll be lost on this question, but it's very simple. b squared minus 4ac is the discriminant, and there's three things that can happen with the discriminant. Learn them off and you'll never fall down on this question.